Good morning, everyone. I didn't get a chance to actually be here. I have to be at a funeral with my husband, so I made a video of our notes so you can follow along. I'll try to leave a list of times that you could skip to if you feel confident about certain parts of this notes, so you can skip around and then review if you need to do so, okay? So this is our 322 notes, and we're continuing on with our complex numbers and powers of I. We are going to just touch on this, and then we're going to be done. And then we're going to move right into quadratics next week. So let's go ahead and get started. The number I is the unique number for which I equals, right here, I equals square root of -1. And in turn, if we double that, or not double, but multiply it with itself twice and have I squared, it is equivalent to -1. So imaginary numbers are any numbers that can be written in form of a plus bi, where a and b are real numbers and b does not equal to 0. A can equal to 0, but b cannot equal to 0. If we have imaginary numbers, so for example, if you have 3 plus or minus I, it still is a 1 for b. So this is not 0, so this works. This is an imaginary number. You can also have no a at all, and it's a 0, and have plus or minus 2i. You just can't have 0i. That looks like oi. It doesn't work. This doesn't exist. Okay? Let's see. Complex numbers. Any numbers that can be written in form of a plus bi, where a and b are real numbers. Note a and b both can be 0. So the union set of all imaginary numbers and all sets of real numbers is a set of complex numbers. The moment we have an I, it's an imaginary number. The moment that we have either one of those, it's going to be a complex number. Okay? So it can be all imaginary numbers or a set of all real numbers. It can be both. Okay? So we are going to go through how we add and multiply, add, subtract, multiply imaginary complex numbers. Okay? Imaginary and complex numbers. So addition, we combine like terms. Okay? The way we combine like terms, we have to make sure that everybody's out of the parentheses. So I'm going to rewrite it with 2 minus 3i, since this is positive on the outside. But since this is a negative, which is also a subtraction sign, we're going to distribute that to each of those terms inside the parentheses, making this 4 a -4, and making this 6i, that's -6i, positive 6i. Okay? And then we're going to combine like terms. So real with real, and then imaginary with imaginary. Okay? So the real terms are going to be together -2, and imaginary ones are going to be positive 3i. And that's it. That's how you add or subtract. Okay? When multiplying the square roots of negative real numbers, begin by expressing them in terms of I. So instead of multiplying them like the inside together and then ending up with a positive 32, we don't do that. Okay? So we have to separate them out with square root of -1 times square root of 4. That would be the first set, and that would be I times 2. And then multiply that with square root of -1 times square root of 8. 8, when we simplify them, it becomes 2 rad 2. -1 becomes I. So when we multiply these 4 parts, it's not terms because they're separated by multiplication signs. 1, 2. Those 2 become I squared. And let's see, let me change the color. 2 is a real number. This 2 is a real number. So we multiply those 2 and get 4. and the rad2 remains as rad2, like so. So we know that I squared also is equivalent to -1. So we would change that to -1 and then multiply it with 4 rad2. So when I do that, this is going to be -4 rad2. This is the correct answer. There is no positive 4 rad2 because if you did what I told you not to do, which is to get square root of 32, when you break it down, 8, 4, 2, and 4, you would pull out that 4, have the 2 left over inside as a radicand, and this would actually be the positive 4 rad2. But like I said, this violates that rule of having negative radicand. Okay, so you have to break it down like so, and then work your way down to a solution. Okay, here we go. Multiplication. Okay, so some of you guys already know how to FOIL. FOIL stands for first, outside, inside, last. Okay, it refers to the sets of terms between two binomials that you are multiplying. Okay, so the first, I'm going to try to color code it. First, I'm going to color code it with 2 times 8, and we get 16. Outside refers to 2 and -7i because they're on the outsides of the binomial. So that would be negative 14i. And then the next one is inside. So inside terms would be 3i times 8. So let me get a blue one. 3 times 8 is 24, so positive 24i. And then the last one would be the last terms of each of the binomials right here. So that would be negative 21i squared. Negative 21i squared. So from here, you would start simplifying it and then move through to get to a simplified complex answer. That's one way to do it. Let me continue color coding this. Last was in red. Inside was in blue. And outside was in green. Okay. There's another way to do this, and I've shown my Algebra 2 students to use the box last year when we multiply binomials. This, I think, is much easier, and we take away the potential mistakes that you could be making when you're multiplying binomials. So I would put one of the two binomials on top for each of the terms, and then the other binomial on the side, and we multiply like a Punnett square. Okay, so 2 times 8 is going to be same as my first term that I multiplied in FOIL. So 2 times 8 is 16. And then 3 times 8 is my inside. So 3 times 8 is going, let's do 2 times 7i. Negative 7i, we get negative 14i. And then we get the inside, 3i times 8, which is 24i. And the last one we are multiplying together would be 3i times negative 7i. So that's negative 21i. You can use either method. You can use the FOIL. This is the FOIL method. Or, FOIL method. Or you can use the box method, which is also called the area model. Okay, I know you guys that are taking biology have heard the Punnett square kind of a thing where you guys figure out the genetic combinations of two types. You can see that here as well, and it's the same idea. Okay, so in the box model, you can combine these two because they are of the same term as we can combine these two from FOIL. So when we combine negative 14i and 24i, we get 10i. We get 10i here as well. 10i. So we would rewrite the next line with, let me choose a neutral or different color, 16 plus 10i minus 21i squared. Okay. Another thing we can simplify is this I squared. I squared equals to negative 1. So 16 plus 10i minus 21 times negative 1. When we simplify these two, it becomes positive 21. So it's 16 plus 10i plus 21. Now we have 16 and 21 that we can combine like terms for, which gets me 37 plus 10i. And there you go. That's how we multiply binomial complex numbers together. Okay? Division. So division is a little more complicated than multiplying. You do both. You multiply and divide when it comes to dividing complex numbers. So when dividing a complex number, it says to 1, multiply the top and bottom, okay, by the complex conjugate. Complex conjugate is basically the same terms, like so, same terms, but it's the opposite operation, okay? So what's given to us is 1 minus 5i. The complex conjugate would be 1 plus 5i over 1 plus 5i. It's important that you could keep this as a value of 1 because 1 plus 5i over 1 plus 5i is identical top and bottom, which makes it a whole 1. We want to multiply this by whole 1, and we don't want to change the values of what we're trying to divide. So it must be a whole 1. It needs to be identical on top and bottom. Okay? And I erase all those marks so it's not so distracting. All right, so let's go ahead and give it a try. We start with the problem. This is the problem that I've given you. This is the problem. And I'm going to try to multiply with its conjugate. Multiply by complex conjugate here. Let's see. I'm going to use the term. This is my complex conjugate. This guy, the whole thing. Okay? As a whole 1. So when we multiply those two, we get 2 plus 3i times 1 plus 5i and over 1 minus 5i times the quantity of 1 plus 5i. Okay, so this is when this multiplication method comes in handy. So it's a lot of work, but it should be pretty easy. If you know how to use FOIL, go for it. FOIL or use area model, aka box. Okay, so I'm going to use the box because it's a lot more visual for those people that are kind of new to multiplying binomials. So that's 2, 3i, 10i, and 15i. Okay, oh, I squared. Then I would write 2 plus 13i plus 15i squared for the top. For the bottom, I'm going to change it to green. So I'm going to do this part in green here. Okay. So another box. And I have 1 minus 5i and 1 plus 5i. So 1 times 1 is 1. 1 times negative 5 is negative 5i. And 1 times positive 5i is still positive 5i. And 5 times 5 is 25, negative 25i squared. So I'm going to go ahead and write that. 1, and then 5i plus negative 5i gives me no more 5i. They actually cancel each other. So remember, we can't write 0i, so we're just not going to even write it. So we're going to put minus 25i squared. Okay, now we're going to simplify the I squared by multiplying the coefficient to those imaginary I squares with negative 1. When we do that, it's going to look like this. 2 plus 13i plus 15 times negative 1. And the denominator would look like 1 minus 25 times negative 1. Okay. Now, I'm going to go ahead and multiply these guys together. Oh, actually, this is negative. Let me try that again. It should be negative 25 times negative 1. So the numerator will be 2 plus 13i minus 15, because positive times negative is negative. Oops, sorry about that. 1 plus 25 is what we have in the denominator. Okay, I think I skipped a step here by using the area model, so I'm just going to probably end up answering it on the first equal sign here. Okay, so I'm going to go ahead and simplify these steps. Let me choose a different color. Green will be good. Negative 15 and 2 can be combined because they're like terms, so that's negative, let's see, 13 plus 13i. Okay, and then the denominator would be simply 26. Okay, oh, there is one more step. 13 and 26 are factors, and they have a close relationship. If I double 13, I get 26, right? So what I'm going to do is I'm going to factor out the 13, okay? And I get 13 factored out, I get negative 1 plus I. Okay, so if I distribute that 13 back in, I get negative 13. And if I distribute that 13 to I get 13i. So I basically just kind of divided it out, so that way I have one term times another group of terms. Then I have 26 here, which is same as 13 times 2. So I can simplify this and get 2 left over, right? So this final answer will be negative 1 plus I over 2. I know, it was a lot of steps. If you need to watch it again, go ahead and watch it again, okay? I'm going to go into example 2, which is 14 over I. 14 over I, here we go. So we need to first multiply by its conjugate, and like I said, it needs to be a positive opposite, so it would be negative I over negative I, okay? So 14 times negative I will be 14i negative. Negative I times positive I will be negative I squared. Okay, then we're going to change the I squared to negative 1. And I have negative 14i over negative times negative 1. Then I get negative 14i over positive 1. Then my simplified answer will be simply negative 14i. Okay. All right. Next, we did this on either Tuesday or Wednesday. Actually, we did it on Tuesday. In the Tuesday lesson, 3.2.1, it was part 2. Okay. We discovered that 0 power, I to the 0 power is equivalent to 1, because that's always, anything raised to the 0 power is 1, right? This is from like exponent 101, like I think it was in 7th or 8th grade you guys learned that. And then I to the first power is going to be just simply I to the second power is negative 1, I to the third power is going to be negative I, and then I to the fourth power is 1 again, and repeating the pattern, right? So there are 4 distinct patterns that will cycle through every time you have that raised power. So these are the steps that I laid out for the questions that we answered in class for part 2. If you would like to review it again, I'm going to go ahead and go over it. If you don't want to watch this again because you got it, you can skip over to the next part, okay? So those of you that need another review, I'm going to go ahead and do the steps that it says. So I'm going to take my I to the 25th power, take the 25, and divide it by 4, which looks like this step right here, okay? 25 divided by 4 has 6 and 1/4 as your answer, right? Quotient of 6, that's the whole number. and remainder of 1, that's the numerator, okay? So since the numerator is 1 or the remainder is 1, we're going to look for the first pattern, okay, in the, I guess the 4-piece pattern here. So we're going to rewrite it, write I to the 25th power, and then write, oh, we don't have to do all this. Nah, skip it. We don't have to do all that. Just skip it down to I to the 25th power. Yeah, I don't agree with this. It's too much work. I want you to just write I to the 25th power equals 2, since it's equal to the first pattern. So I'm just going to put 1 and be done. Okay? Skip step 4. Forget that. And then because the power of I cycles through 1, I, -1, and I, these types of problems can always be simplified by noting what remainder is in step 2 above. So there you go. There's a simplified version of it. I would not recommend that you go through all of these steps that laid out, because I don't want you to get confused. So just go ahead and just write I to the 59th power equals to -I. Okay? All right. Here we go. Oh, -I in our notes for yesterday, I said to write negative square root of -1. You can change that to -I. Okay? All right. So this is your practice. That's it. So I guess if you skipped, you can go ahead and start your practice. It's pretty easy. And there's the bell. So I have to start period 1 right now. The answers are below. The work is not shown. So if you would like to see the work, you'll have to wait till tomorrow to see the work if you need that. Okay? You are welcome to help each other within your team. Try to stay within your teams today. And that's it. I hope you guys enjoyed my lesson via video. If you have any questions, email me, text me, whatever. Message me on Schoology. And good luck.